Welcome! Today we're exploring green hydrogen fertilizer factories, a groundbreaking innovation showing how renewable electricity can transform into the food we eat. We'll journey through the entire process, understanding each crucial step in making sustainable fertilizer a reality. This journey begins with renewable electricity, harnessing power from wind and sun. This energy drives electrolyzers, splitting water into hydrogen and oxygen. The hydrogen is then compressed and stored, becoming the key ingredient for ammonia synthesis, which eventually leads to the fertilizers that feed our world. At the heart of the process is the electrolysis hall. Here, purified water enters specialized units called electrolyzers. Using electricity, these units separate water into its fundamental components, hydrogen and oxygen. The hydrogen gas, crucial for our fertilizer, is meticulously collected at this stage. Once the hydrogen is generated, it needs careful handling. We compress the hydrogen to high pressures and store it in large, secure tanks. This step ensures a steady, reliable supply of hydrogen, preparing it for the next critical phase in the fertilizer production journey, despite varying energy inputs. To make ammonia, we also need nitrogen, which comes directly from the air around us. Our air separation unit compresses and cools atmospheric air, then uses cryogenic distillation to efficiently separate the nitrogen. This pure nitrogen is essential for the subsequent ammonia synthesis process. This is where the magic happens. The Haber-Bosch synthesis loop. Hydrogen and nitrogen react under intense pressure and high temperatures within a specialized reactor. This precise chemical process combines them to form ammonia, the foundation of all nitrogen-based fertilizers. Efficiency is key. In the ammonia synthesis process, not all hydrogen and nitrogen react immediately. An ingenious recycling loop captures any unreacted gases, feeding them back into the system. This maximizes conversion, reduces waste, and optimizes the overall production of ammonia. Integrating fluctuating renewable electricity with a continuous process like ammonia synthesis presents a unique challenge. Our flexible electrolyzers and smart control systems ensure that the ammonia reactor remains stable and productive, even as energy inputs naturally vary throughout the day. After synthesis, the ammonia is cooled to an incredibly low temperature of -33 degrees Celsius. This cryogenic cooling transforms it into a liquid, allowing for safe and efficient storage in massive insulated tanks. From here, it's ready for distribution, often to distant markets. Once stored, liquid ammonia is ready for its journey. It can be moved through pipelines or loaded onto specialized chemical carriers like ships. This robust transport and distribution network ensures that this vital ingredient, whether as ammonia or converted fertilizer, reaches agricultural markets globally. The entire system represents a harmonious flow of energy. Renewable electricity powers the initial hydrogen production. This hydrogen then fuels the chemical processes, culminating in the creation of fertilizer. This sustainable chain ensures our food production minimizes its environmental footprint. Certain regions around the world are particularly well suited for green hydrogen and ammonia plant development. Areas with abundant renewable resources like deserts for solar, coasts for wind, or regions with significant hydropower potential are becoming global hotspots for this green industry. The primary purpose of green ammonia is to nourish our crops. Once produced, it's converted into essential nitrogen fertilizers like urea and ammonium nitrate. These fertilizers are crucial for boosting crop yields, directly improving food security, and sustaining agricultural productivity worldwide. Beyond agriculture, ammonia is emerging as a powerful energy carrier. It can be used to produce fertilizers, but it also offers a way to transport hydrogen efficiently for energy applications. This versatility makes green ammonia a cornerstone for both food and future energy systems. Ammonia serves as an excellent means to transport hydrogen over long distances. We can convert hydrogen and nitrogen into liquid ammonia, ship it across oceans, and then, at its destination, crack it back into hydrogen for energy use, or keep it as ammonia for agriculture. These green hydrogen ammonia fertilizer plants are complex industrial ecosystems. They seamlessly connect renewable energy, advanced chemical processes, and sustainable agriculture. From capturing sunlight and wind to putting food on our tables, it's a truly integrated and impactful operation.